Hi everybody, how's everybody doing today? My name is Justin Marquis. I work over at Acuity as a support engineer, also a Argo CD maintainer, and a local avid scuba diver. So today we're going to bring you GitOps best principles using Argo CD. I'm here with my colleague, Christian Hernandez.
Yeah, so Christian Hernandez, I am an Argo CD maintainer, Open GitOps maintainer. I'm a head of community over at Acuity, and I'm a musician and guitar player. So for those who want to talk about guitars later, you can wave me down. Cool. So yeah, so we're going to go ahead and get started here. We're going to be talking about a lot of things today. We're going to talk about like GitOps in general, how to set up your repository structure, talk about Argo CD components, talk about application sets, all these like kind of like best practices to like get up and running. Some of the things that you need to like look out for in order to get the most out of your Argo CD installation and your GitOps practices. So, and then we're gonna wrap up about how to get involved in the community, where to go, where to start, if you want to get involved in the community, and then we're gonna talk about other projects we're involved with, talk about Cargo and what that gives you, kind of further expand like your GitOps journey there. So I'm going to talk about something that I can probably spend a whole hour talking about, and it's just GitOps in general, right? The GitOps principles. And so a little history about GitOps is that the term kind of came up early in the Kubernetes, I guess, journey. There was this company called Weaveworks that actually was set up as a cloud provider using Kubernetes and containers and things like that, and they lost, I don't know how many of you have, I have done this myself, is they somewhat fat-fingered a configuration and they took down all of US East 1, right? So basically half their infrastructure, someone fat-fingered something. So the what ended up happening is that, okay, let's recover, and like it took about 30 minutes to recover, and most of that was getting storage back online. So Alexis Richardson, being the CEO, instead of getting mad, he asked, whoa, how did we come up so fast, right? And his engineers, his SREs, were explaining the processes that they were using, right? Using Git as a source of truth, using a controller in order to reconcile things, and he goes, oh, this is kind of GitOps, right? And so GitOps started kind of like as this, idea or this way to describe kind of like how they were doing infrastructure as code with Kubernetes along with a source of truth. So later on it became more of like a practice, and a bunch of us got together from the Flux community, from the Argo CD community, people from Red Hat, people from AWS, right, all the usual big players, to start the Open GitOps project, right? So the Open GitOps project aimed to kind of put some principles around like what it means to do GitOps, right? And so we came up with 4 principles. First of all, like a system operated by GitOps is declarative, right? And so system managed by GitOps must have its desired state expressed declaratively, right? We have YAML and we have Kubernetes. So that is the declaration, right? There shouldn't be instructions on like how to do something, right? It should just be describe the end state. The second principle is that those desired states, those declarations, must be stored in a way that's versioned and immutable. This is where Git comes from. So the term Git, because Git is something that is versioned and immutable, right? Keeps complete revision history, that sort of thing. But it doesn't necessarily have to use Git, right? You can use things like OCI, you can use SQLite, technically, is versioned and immutable. And pulled automatically. So I always spend a little time on pulled automatically because people automatically think, oh, you're talking about a push versus pull system. No, not talking about that at all. Throw that thought away. I'm not talking about that at all. I'm talking about how the system retrieves those declarations, and it retrieves it in a pull fashion, meaning that basically separating it from an event-based system, right? You have an event-based system, right? Webhooks, some sort of triggers. All of that is something that shouldn't be relied solely on, meaning that you'll have webhooks, right? You'll have like an event-based system in GitOps, but relying on an event-based system solely is not GitOps. You need some sort of controller that automatically looks for revisions outside of outside some sort of event. And so, and then the last principle is that it's continuously reconciled. So all of that happening, and it's continuously happening in a loop. So I always describe GitOps as, as an air conditioning unit, right? As a wall air conditioning unit versus a central AC system. I remember straight out of college, my first apartment, I had a wall unit. It was awesome. It was the first AC I've ever had. Growing up, I never had an AC, so when I got my first apartment, I had a wall unit, right? And it was awesome. But it was something that I had to turn off and on, right? I had to, I got warm, that's an event. I had to get up, go, and turn on the AC. Once I got cold, that's another event. I had to stand up and go and turn it off. Whereas GitOps is like a central AC unit in my house today, where I set my desired state, right? I go up to the thermostat, I set, I want it at 72, right? I like it a bit warmer. I set it to 72, and I leave it alone. And there's a controller, right? The thermostat constantly monitoring. If it gets too hot, it'll turn on the AC. If it gets too cold, it'll turn it off. So GitOps is basically the central AC unit with the thermostat. You set it once, and there's a controller monitoring there. There's no longer an event. You do an event, I'm like, you know what, I want the AC off, right? Like, there's obviously events, just like in GitOps, right? There's events that you want happening, but I don't rely solely on those events. I have a controller helping me out. And that is the gist of GitOps. So, and so that, now talking about GitOps, now there are tools that do that for us, right? We have a bunch of YAML. We're managing a Kubernetes system. We want that YAML to be deployed. And so we store that in Git, and we have a controller that monitors changes, right? Whether it's a change in your source of truth in the Git repository, or there's a change on the system itself, right? Someone does an out-of-band change, right? I go in and I delete a deployment, or I change the replica count. The controller will then look at your source of truth and then switch it back. Or if the replica count changes in Git, it would change the system state. And so there's tools out there now that do that. Flux was one of them, and Argo CD is another one. So Argo CD is a open GitOps compliant tool for Kubernetes. So with that, I think Justin's going to go over some of the components of what Argo CD is.
How many of you out there are currently using Argo CD? That's a good number of hands. How many of you understand all the controllers and how they work together? All right, that's perfect. So let's go ahead and go over that. Here you can actually see the controllers here. Here in the center there's the core controllers. These are your main controllers that operate the Argo CD. You also do have the API server, which interacts with the CLI, gives you the beautiful UI everybody knows about. But here in the middle, the core, these are going to be our most interesting controllers, and we're going to start here at the core, the heart, the application controller. The application controllers there, it's responsible for looking at the live state of your cluster and the desired state and reconciling those differences. While doing so, it does manage and establish a watch on all resources on a cluster that it's looking at. So it's a very powerful controller. It is the heart. Whenever a change is detected in Git, that's the repo server's responsibility. It's going to go out, check that. Application controller is going to reach out to the repo server and say, hey, are there any updates? Repo server will respond back saying yes or no. If it is yes, the application controller will take those manifest and then reconcile the difference. And that's basically how that works. Down the lower, we do use Redis just as caching. The UI is pretty heavy when you have a lot of resources. Rather than having to keep reconciling that, we do store it in cache to improve speed performance. We're going to start off with some basic installation recommendations. Here at Acuity, I work with large corporations, small corporations, and I just kind of want to share the best practices that we see. A lot of people, they ask us, should I use the Helm charts to install Argo CD? Should I just use the customized charts? In the end of the day, it really doesn't matter. It's what works better for you. Preferably, I like customize. I've seen installations where customers running nearly 50,000 applications and they're using the basic customization charts. The Helm is slightly opinionated. When you go to upgrade Argo CD versions, if you want to stay to a minor release, it's much easier if you have the full power with the customized charts. Talking about sharding. A lot of people ask about sharding. When should I start sharding? Sharding, if you're just deploying to a single cluster, you don't need it. If you're deploying to a lot of clusters, let's say 100 or more, you're going to have to enable sharding so you can distribute the workload for the application controller. Typically, when you start managing a cluster and you see it's managing around 70,000 resources, you'll start to see some performance impact, and then you might want to think about possibly scaling up and enable sharding. When you do start scaling, the repo server scales very well. It's responsible for reaching out to Git, generating those manifests. It requires a lot of CPU, a lot of memory when you start generating numerous manifests. So you can see here I scaled using customize to 4. This scales up real nicely. You can increase that as you need, and as the metrics start showing you that you need more work. The next thing people have a question about is the status processors and the operation processors. The application controller basically has 2 queues. Oh, yeah.
Yeah. There you go.
How's that? All right, thank you. So basically, the application controller has 2 queues that it performs work. It's a status processor, and then the operation processor. Basically, the status processor is responsible for updating health checks, checking the status of the application, if it's out of sync, if it's in sync, and then you actually have the operation processor, which is responsible for performing kubectl apply. By default, the status is set for 20 workers and 10 workers for operation. Typically, when you start deploying in the high hundreds of applications, you need to start increasing these. It basically gives more workers to the controller and allows it to perform more responsibilities. And another one that we highly recommend. By default, if you have a self-heal function enabled, which basically the controller is watching the resource, if something changes that it's not supposed to be in the desired state, within 2 seconds by default, it'll go ahead and do that. We found that increasing this anywhere from like 300 seconds, from 2 seconds. If you get an application that's either misconfigured or you have some sort of mutating webhook that makes a change to the resource, the controller gets real angry and it starts fighting. It tries to reconcile that difference. It's saying, this is the desired state, it's not the desired state, and it gets in a loop. And it starts using up CPU and memory as well. And you start seeing performance impact. So this setting right here for the self-heal timeouts, adjusting that gives you a lot more flexibility.
Yeah, and just a quick note on that. Like, so when I talked about GitOps being, like, you're going to have event-based things set, right? Like, so someone's like, well, why would you set the reconciliation timeout like higher, right? Don't I want it constantly checking? Well, like, you're going to get performance issues. So that way, now you have a way to tune the timeout on when the reconciler runs, and then, but you can also have your event-based thing. So you'll definitely have both.
And coming from there, starting off smart. By default, Argo CD comes with the default project enabled, which gives full permission to deploy to any cluster, use any repository, don't use it, turn it off. Start taking advantage of Argo CD projects. Argo CD projects basically enable you to logically separate your applications. Using single sign-on, you can break it up to different teams. Argo CD's a full multi-tenant platform. So you break it up, use single sign-on, don't use the default project. Just as an example here, you can actually see this is how you would restrict the default project. basically you're not going to allow any source repos, any namespaces, any of the destinations of any resource. Just restrict it. As an example, this is another application or app project we created here, which you can see it does allow you to deploy any type of cluster resource, but it's restricted to the in-cluster, any namespace, and then it specifies a specific list of repos that are allowed to deploy. If you try to deploy anything outside of this within that project, you cannot. So please disable the default project. Don't use it. It's only there basically for onboarding, learning Argo CD, and making it easy to adapt. And the last recommendation here on installation is actually using the app of apps pattern to actually have Argo CD self-manage itself. I do run into a lot of people, they're still using kubectl apply to upgrade Argo CD. When they already have Argo CD on their cluster, use it itself, let it manage itself. It's real easy, and it's just a simple app. And I'll hand it off to Christian.
Yeah. So, so I want to spend some time talking about Git and repository structures and things you need to keep in mind. Git's going to be very, very central to what you're doing in GitOps, what you're doing in Argo CD. So anything that you do in Git, Argo CD is basically going to do what you tell it to based on Git, right? So when I talk about repository structures, people say, okay, well, I'm using Argo CD, I'm getting started with Argo CD. I have a large team, I have many teams. Like, how do I set up my repository structure effectively in order to, take advantage? Like, what is the best practice there? Like, what is, give me a template, right? Is usually what people ask me, right? Like, just give me a template. And I go, unfortunately, I cannot, because repo structure is dependent on something called Conway's Law. Who's familiar with Conway's Law? A little bit. Okay, so for those who didn't raise your hand, Conway's Law basically is says you design your system based on your organization's communication structure. So basically, repository structure in GitOps falls in that same category, right? I can give you a template, but if it doesn't work for your team, if it doesn't work for your organization, right? Whether your organization is very, very siloed, whether there's concerns in terms of regulatory concerns where no, people can't access this and you need blah, 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 right? There's just a slew of things to take into consideration. So there's no kind of one true GitOps repository that works, right? It's just impossible. Because of Conway's Law, right? It's going to depend on your organization, right? GitOps is basically Git workflows. So how your organization does those Git workflows is going to affect your repository structure. So that being said, it doesn't mean we leave you, I guess, all puns intended, high and dry. But there are some basic best practices, right? And the first one is dry, right? Don't repeat yourself. It's kind of generically, you have all this YAML that you want to deploy, and you have all these environments you want to deploy that YAML to, and the variance between environments is maybe 1 or 2 lines, right, of YAML, right? So instead of connecting to this database, you connect to this database, but the rest is the same, right? The delta between the two is very, very minimal. So, but that doesn't mean you have to copy the same YAML and just change one line, right? You can use things like what we talked about before, Helm, right? You can use Helm to not, templating to not have to copy and paste a bunch of YAML. You can use Customize, right? You can patching framework like Customize. You can use what you'd like, really, in Argo CD because of the plugin mechanism. Like, you can use YTT if you like. You use a JSONet. I think people still use that. And so, whatever works out for you, whatever, basically don't repeat yourself, or I like to say don't repeat YAML, I guess, because it's kind of a pun there for Kubernetes users. Also, you're gonna separate your source code source code versus the deployments that deploy that source code, right? So, and the reason for that is there's just different life cycles, right? Coding life cycles. There's software engineers or whoever's coding are making constant changes. They're constantly iterating from the application, right? And if you have a team, that's even expanded even further out than that. So whereas YAML or deployment of that of those things actually have a shorter, or it doesn't change as often in terms of deployment, right? And so you know, being like an SRE, right? Like you can just imagine the source code repository constantly changing, and you're like, well, is that touching my environment? Is it not touching my environment? And you have to, there's workflows that you don't care about. So those are two separate workflows. Those are two things. It's like, just kind of just separate your source code from your YAML, because you are promoting manifests versus promoting code, and there's just completely different life cycle, right? And so those are kind of just some of the things that you talk when you talk about GitOps and, like, you know, where to get started. All right, let's separate the concerns is one of them, right? And use templating, right? So in order for you to get the most out of your YAML, right? And so people ask how many repositories. It's like, well, like, you know, okay, should I throw everything in one Git repo, right? Like, so my environment is just in one Git repo. Is it many Git repos? Is it X, Y, Z, right? So there's really kind of like two schools of thought, right? So one of them is what we call a mono repo, where people mostly start out here. And so I have a sample Git repo here, but basically what you're gonna do is that you're gonna have a mono repo, meaning like I'm gonna have everything in one repository, right? So mono repo means something else to coders. So I'm talking specifically with GitOps. There's a mono repo aspect of it. But like there's things like, all right, I'm gonna have all of my components, right? All like the Argo CD specific things in a specific directory structure. I'm gonna have core components, right? Like configurations, things that what we call cluster add-ons, which we'll go over in a bit, and any of the tenants that are in your environment, right? Like these might be application deployments, these might be teams, it might be, you know, sort of, you know, one things that that belong on the cluster, but you don't necessarily, it is, as an administrator, you don't necessarily deal with a lot, right? They're just tenants on your cluster. Whereas these other things that are separated by other directories here, those are kind of maybe things that are, as an administrator, you interact with a lot. And then I have, I always have this bootstrap, right, which I think we're going to go over app of apps in the next couple slides. But I have a bootstrap directory, right? It's kind of like the chicken egg thing. Justin was talking about Argo CD managing itself, but like, how do you get it to that point, right? Like, how do you get Argo CD to manage Argo CD without having Argo CD installed? Because then you need Argo CD to install Argo CD, right? Like, there's this like whole thing. So I always have like this bootstrap kind of point of entry, because this, as you can imagine, can get kind of big. It can get, especially with a lot of clusters, with a very, very busy system. You want a way to be able to deploy everything with one kind of command, essentially, is what that bootstrap directory is for. And so, another way of doing it, and this is kind of like what I settle on, or what people settle on later on after they've been using Argo CD for a while, and, you know, the organization grows, is I like to call them polyrepos, but basically it's many repositories, Git repos, depending on, you know, what the thing is for, right? And so this is kind of, this pattern is actually something that they use at Intuit, right? And so at Intuit, they do minimum 2 repositories, right? One, what we call a control plane repo, which is basically all the things that you need in order to get the cluster up and running, things that are configuration for the cluster, things that basically is like, you know, you have a naked Kubernetes cluster with nothing on it. Where do you start? That's the control plane repo. And what we call a control plane is like, that's your point of control for that cluster, right? That this is where like the admins live for that cluster. This is kind of like their repo, and this is like their point of control. I have, this is like very, very bare minimum, right? Basically, it just installs Argo CD and that's it. But I set it up similar to that other repo where I can start adding things, right? Like I have a directory called system, meaning like what are the system components, right? Argo CD, maybe I want to install Kyverno, things like that. Configurations live on their own, and then I have a bootstrap basically to kind of, as you know, you can see here, when I install this, I target the bootstrap directory, and so so that's one repository for this one cluster. There's two repositories then. Then you have an application repository, which is basically just a repo with the deployments, right? Like here, we're using customized for overlays, right? Depending on what I'm going to do, EKS, GKE, I have a default, right? And so this is just deploys the application components. So if I go back here, and I go to base, like this is a very simple example of a deployment and a service, right? All of that. So all just kind of just what deploys this specific application, this Go blue-green application, lives in this repository. So then basically I kind of hand off the responsibility to that team, right? It's like, okay, you manage your deployments and repositories and things like that. And then, whenever you're ready to release something, tell me what tag it is, and I'll switch the tag, and then we'll do a release that way. So kind of like a high-level overview. So other things in terms of repository structure, Git workflows type of things, is that GitOps workflows, there's an instinct of people who have done Git workflows to use Git flow. Basically, it's like, oh, I'm going to have a branch for dev, I'm going to have a branch for stage, and then when I'm ready to upgrade from dev to stage, I'm just going to merge those branches. And like in GitOps world, that does not work. That never works because the difference between dev and stage isn't the deltas between the two, because in dev, you may be connecting to a dev database, and in stage or production, you're connecting to the productions database. So like that merging is just never going to work, right? Like you just can't simply merge those branches. So don't use Git flow. Use something called trunk-based development, right? Basically trunk-based development is you have a single trunk main, right? We just call it main. It doesn't have to be main, but you have a single trunk of main, and you have short-lived feature branches or release branches, meaning that, okay, I'm going to make a change in dev, make me create a branch, make my change, submit a pull request to that, to the main branch, and then when that gets merged, then the GitOps controller deploys it. How you control what gets deployed is based on these, I don't think I have a good example here. I'll just do this here, overlay. So here, instead of clusters, it can be environments, right? These directories can be called a dev, stage, production. And so when I make a PR, I'm going to change the things in the dev directory. And then once I merge it, then it gets automatically deployed to dev. So, so I would, trunkbaseddevelopment.com if you're unfamiliar with trunk-based development. But the idea is you have a single trunk and short-lived feature branches that always get merged back into the trunk. Rendered manifest. So the rendered manifest pattern basically is a way to, let me make this a little bigger. So when you store something in Git, either it be Helm, whether it be customized YAML, Argo will then take that and it'll run customized build on the fly at runtime. It'll run Helm template and then deploy that Helm repository. So Argo actually takes what's in Git and then it will actually render it out to the Kubernetes cluster, right? This is fine, and this is it even scales pretty well if it is, as Justin was saying, if you're like tuning the repository controller and things like that. But if you want to really get the most out of your Argo CD installation in terms of performance, we do something called rendered manifest. Means the rendering happens before Argo even touches the YAML, right? So for example, Helm, right? Helm template, right? It'll just spit out the YAML. Instead of Argo CD doing that, you do it, right? And then it ends up looking like this. You do it actually in CI. You push that to CI. So what ends up happening is that you make some sort of change in your Git repo. There's a CI system that does the rendering of it, right? Either the Helm template or customized build, and then it'll store that somewhere. And then Argo CD will then pick it up and deploys it as is. So what that buys you is you save the compute, the memory, CPU, from Argo having to do that. And in a very, very busy system, that repo server can get really overloaded actually pretty quickly. And so this is just something you can do in terms of tuning and performance that will make Argo CD faster. So again, I could probably do a whole presentation on rendered manifests. There's a bunch of them out there. And then there's, if you're using a mono repo, right? So if you're using a single repository, there are scaling considerations. Basically, the repo server is something you need to look for because anytime someone makes a change, the repo server is going to kick off. Even if there's a change to one app, it's going to affect all the other applications. Just because you need to, the repo server needs to re-download, right, those things, right? And so there's a cool pro tip. I actually I didn't know about this until Justin told me, right? And so when Argo CD runs, I think, a Helm template, right, that's a serial process. So if you have like hundreds and hundreds of Helm deployments, thousands of Helm deployments, they wait in a queue, essentially, because it's a single process, right? And so a pro tip is to turn on concurrency, meaning like let's take advantage of all those threads we have on these computes nowadays, right? We don't no longer need to do serial processes, do all these in parallel. I believe in Argo CD version 3.0, that's going to be the default. So I just found that out today. Thank you, Justin, for telling me. That's going to be the default. So this is, hopefully, this is not something you should need to worry about for too much longer. So I'm going to talk about a little bit about what an application is, and then I'll hand it over to Justin. But what an Argo CD application is like, so we keep talking about applications, deployments, right? So how does Argo CD deploy this? And it deploys this with a CRD called an Argo CD application, right? And so what an Argo CD application is basically a unit of work it's the smallest atomic unit Argo CD uses, meaning that you give it a source, right? In this instance, we're doing a Git, right? A source can be a Git repository, a Helm repository, pretty soon an OCI repository, so stay tuned. And then you give it a destination, right? So a destination is basically a Kubernetes cluster with a namespace, right? And so, and here we're deploying in what we call in cluster, right? That's the shorthand version of saying deploy these YAMLs in the same cluster that I'm running in. And you give it a namespace, and it should be able to, it'll deploy it then. So something to remember, this is a one-to-one in terms of source or sources, and we'll talk about sources in a little bit, to cluster, meaning that you designate which cluster it installs on. For this example application, if you have 3 different environments, you're going to have 3 different application definitions. So it's a one-to-one. Just something very important to remember for Argo CD applications is a one-to-one relationship between source or sources, and destination. So it's pretty flexible, right? So there's things that you can do, like sync policies. Some of the sync policies that I always turn on is auto sync, right? Sync policies is automated, and I always turn on pruning. You may or may not want that. What I always do, so pruning basically means if it's on the cluster but it's not in Git, I'm going to delete that. So meaning that's like, I like to call that the true GitOps, right? Kind of switch. It's like if it's not in Git, I'm deleting it. So if anyone adds anything to the cluster, it's going to get deleted. You may or may not want that, right? You can flip that switch, right? So you can turn off pruning. In some cases, you do want to do that, especially if you have outside controllers adding things like storage. You definitely don't want storage to get deleted. Self-heal, I always turn that on. Self-heal is always true, meaning that like if there's any divergence locally, right? Meaning like if it diverts from the source of truth, someone scales something up, you want it to revert back to Git. And so finalizers, right, is another thing. So finalizers, adding a finalizer also is another true GitOps switch, right? So if you don't have the finalizer, what Argo CD does when you delete an application, it'll just delete that definition, but it'll leave the resources on the cluster. But if you have the finalizers on, that's like, again, another true GitOps type of way. If you delete the application, all the resources is referencing, it'll also delete those on those applications as well. So it'll also wait for those things to delete. So it'll, when you delete an application, it'll start the deletion process. It'll first delete all the resources, and then the application will finally get deleted, right? And so now I think talk about extending application. I'm going to turn over to Justin. Talk about what you can do beyond just like setting the definition of an application.
Thank you, Christian. So let's take a look at, you can see this application that's listed right here. This particular application is referencing the path you can see right here, apps. And what you can do is take an Argo CD application to point at one or more or a series of other Argo CD applications. So basically, the root app is the parent, and it deploys child applications. So if in Git you check in another child application, Argo CD automatically adds it to your cluster. What we'll do is we'll take a quick example here using the app of apps. And you can see here in the apps directory, I have 3 different apps. This is actually an app of app sets. We'll talk about that later on. And an application for Argo CD and an application for Cert Manager. So I have a Bootstrap app that we saw earlier, and it takes the path apps, deploys these 3 resources onto the cluster. Argo CD picks them up, sees the custom resources, then creates those apps as well. So it's real useful when you want to scale out. If you have a bunch of cluster add-ons you want to add, you can logically group them in folders and have it done all at once. So it's very, very, very useful feature. Next, I want to talk about Helm inline values, the do's and the don'ts. Christian was talking about config management plugins, how Argo CD has it built in, Helm, customized, JSON.NET, and it could be extended. By default, Helm has quite a few options. In particular, when deploying a Helm application through an application's custom resource, you could do inline Helm values rather than specify a values file, or you can also specify parameters, which parameters take override. But I've seen it in the past where customers and other people are using inline Helm values improperly. Sometimes they'd like to deploy hundreds of these. Please don't do that. Use a Helm values file. What ends up happening here is if you do a bunch of Helm inline values, the values actually get stored in the application resource under the status field. And when you have pages of this with the reversion history, this CR gets huge, and it starts impacting performance. So if you're going to use Helm inline values or parameters, my best case of advice is if it doesn't fit on one page and you have to scroll down, you are doing it wrong. Next thing we're going to talk about is multi-source applications. They were introduced in Argo CD 2.6. This was a huge, huge thing the community wanted. Basically what it does is it allows you to target multiple sources, whether it's a Git repo, Helm charts, and then what it does is it combines those resources, renders them down, puts them into one file, and then applies them. This gives you the ability to deploy applications. In this example, we have a billing app, and then we have a configuration in another Git repo. So basically, it combines them, generates the manifest, and combines them in one source and into one app. So that makes it nice. Another way of using multiple sources is using external values. Let's say your Helm values live outside of another repo. You're able to do that now. Here you can see the repo URL at the bottom. The second source is actually just referencing a list of files in Git, takes those values and applies it to the next source as actual Helm values. A lot of people are doing this. Kind of a guideline when using multiple sources. If you're using more than 2 or 3 sources, you're probably doing it wrong and you need to rethink your strategy. It's not designed to have 5, 6, 7, 8 sources. There is a performance impact not only on the application controller, the repo server, but also Git. Especially if you're self-hosting it, you will start to see throttling. And then that brings us here to application sets. We've been defining applications here. Doing it by hand is time consuming. The old way of doing it was the actual Helm template applications, and everybody kind of had their bespoke process of how they were creating it, and the folks over at Red Hat came up with application sets. Application sets, basically, it's a powerful templating tool that generates Argo CD applications for you. And how does it do this? It has another controller called the application set controller. And its job is just to create, update, and delete application resources. The controller's only job is to ensure that the application resources are consistent and defined within the parameters of the application set resource. What does that mean? Basically, when you create or delete an application set resource, the application set controller responds by creating, updating, and deleting Argo CD applications. It doesn't modify or delete any sort of Kubernetes resources, only the application resources themselves. Typically, it's recommended only by default. This is like an Argo CD admin tool. There are some exceptions, but it's going to be outside of the scope of this talk. If you want to take it and talk in the hallway after, I'm more than happy to do that. We're also going to go over some safeguards. So how does an application set work? It has a tool called generators. And these generators, there's 9 of them right now currently. I have the 4 listed that are the most popular, the list, cluster generator, the Git generator, and a matrix generator, which allows you to combine one or more. What are generators? What do they do? Generators, basically, they're responsible for generating parameters that are then later applied into the template field of an application set. Let's see an example real quick. So this is a guest book. This is the simplest generator there is. Usually this is the best place to start when learning application sets. You can see here the list generator has a list of elements, starting with the name prod, namespace, guestbook dev, and then below it there's the dev, guestbook dev. What the list generator is it takes these parameters. Make it a little bigger. Is it a little bigger? And in the template field here of the application set, you can see we have defined namespace. So basically that parameter is then applied and it creates that application. A lot of people ask too, like, once you apply these, since it's an application set, it's not an application, it actually doesn't show up in the Argo CD UI. So the community's got kind of creative and we have a term that's called an app of app sets. And what an app of app sets is basically just an application pointing to where your application sets are stored in Git. And what that looks like in Git, allows you to have a little bit of visibility, is you actually see the root application here, which shows the application set, and then you can actually see which applications were created from that application set. So that's a little pro tip there as far as seeing visibility on application sets. I know there's a lot of requests in the community to make application sets first class in the UI. It's still being worked on, but that's the way around that. And let me go bring this up. Next, we're going to talk about when using generators. You can also use for post-processing selectors. This can be either match expressions or labels. So if you're using a generator like this here, you can see the key name. The key is the name. Operators in, values are only in prod and environment. If I remove dev down there in the values, it will not create the application set using these parameters at all. It'll just completely negate those. So this is really useful when you're using like a cluster generator, which basically takes labels from all the clusters that you're deploying to. A lot of people, really neat, if you actually label your clusters in Argo CD, you can use then application sets based on those labels to decide what type of applications you want and manage your add-ons. And then, go to the next one. And these are the application safeguards I recommend. As I stated earlier, if you change something in an application set, it's going to apply and update by default. So there's a couple safeguards you can use that you should be aware of when using application sets. The first being preserve resources on deletion. If you add this into your application set under the sync policy field underneath the spec, preserve on deletion, basically when the application set creates the applications, it's going to add the finalizer that Christian talked about earlier. And if you make a change and that application gets removed, all your resources get removed as well. I've seen this where somebody made a change, they weren't aware of how the application set controller worked, and their product instance went down. They were unfamiliar. The other safeguard here is the sync policy. By default, it's set to sync, which allows the application controller to create, update, and delete all applications. There's some other options: create only, create update, and create delete. Each of these are useful using different type of generators. Specifically, like using a cluster generator, it's real nice to just do create update along with the preserve resources on deletion. Very useful. If you have any more questions, please reach out on that. And I'm going to hand it over to Christian to talk about cluster add-ons.
Yeah, so cluster add-ons, I mentioned earlier about the when you have a bare Kubernetes cluster, right, and you bootstrap it with things that you need in order first to control that, right? So that's why I have like the control plane repo, and then I have the application repo. Well, there's also additional things that you want to add to the clusters, what we call cluster add-ons, right? So, these, when we say cluster add-ons, is basically functionality that most, if not all, your clusters are going to need, right? So, at a minimum, you need a cert manager, the external secret operator, right? There's a lot of ways to manage secrets. At Acuity, and I think most people at the Argo project are pretty bullish on ESO, right? Because it's just so flexible, and so you're at a minimum going to need that, and then some sort of policy enforcement like Kyverno, something to enforce security constraints on your clusters. Recommended, right? Not always needed, right? Depending on what you're doing, you need some sort of traffic manager, service mesh. You're going to have that there. Some sort of storage controller. If you're going to do multi-cluster networking, that's like something else that's considered a cluster add-on. And for things that I'm working on, these cluster add-ons are usually deployed either by like a Kubernetes operator or like a Helm, some sort of Helm chart. And for things that I do, these things are usually part of the control plane repo. Actually, what larger organizations do, like very large organizations like Intuit, they actually have this in a third repository. So, so if you're thinking about like large enterprises, you're going to have a minimum of 3 Git repos per cluster or per environment or per Argo CD installation, however you want to say it, but it's going to be at least 3. I have it part of the control plane. For most people, that's probably fine. And that probably makes sense. Makes sense to me. But it's sometimes it's in its own Git repo. So so I kind of just wanted to make a quick note about cluster add-ons. And so since we're running low on time, I'm just going to fast forward real quick on how to get involved. Right. So how to get involved in the Argo project. So the Argo project is a CNCF graduated project, and it's actually the third largest project in the CNCF, right? Only Kubernetes and OpenTelemetry is larger, right? So that's kind of cool to say that. It's actually the 4th, since we're here at scale, it's the 4th largest project in the Linux Foundation in general, which is kind of cool, a little humbling to be said in the same breath as the Linux kernel, right? And so it's really, really large, really, really popular, and it's a really, really large community. So So the best place to get involved is to go to that link there. We put a QR code just to make it a little easier. Basically, attend meetings. If you are, we have weekly meetings specifically for Argo CD, Thursdays at 8:15 a.m. Pacific time. So I'll let you do the math if you flow in from somewhere else. Jump on in, listen, all the lead engineers, maintainers, mergers, all the folks who are decision makers. Actually, we do meet regularly, weekly, to talk about the next releases, what features we want to put in, what bugs there are. People bring up issues, right? And so in any open source project, any open source project, the last bullet point is true. Best place to get started if you want to start your journey in contributing is documentation, contributions is always sorely needed. It is no different in the Argo project. There are tons of, like, I see things that are wrong or could be better in the documentation all the time. My fly swatter, my bandwidth does not let me get to all of them, so probably most is true. So if you are, if you're not necessarily a coder, right, if you're more like me, like on the operations side, right, like is shaky at best, but documentation is always sorely needed. That's I want to say if you want to get involved, that's the quickest way for you to be a hero, not only in the Argo project, but in general. So I don't know if you wanted to add anything else on it. All right, cool. The last thing I want to talk about is what's next in Argo, right? What's in terms of Argo and GitOps. I'm running a webinar to talk about GitOps promotions, right? And so I'm gonna leave this up here for a little bit, but I'm part of a project, Justin and I are part of a project called Cargo, separate from the Argo project, but still open source. I'm gonna be talking about something that I call continuous promotion and how CI/CD needs to evolve now to take advantage of things like Argo CD, things like GitOps, right? And just GitOps in general. So I'll be talking about Cargo, what it is, how it fits into the whole GitOps story, how it expands, and I could definitely do another hour of just Cargo by itself, which I will do. So go ahead and check that out if you have time. And I think with that, do we have